So in this lecture we talk about graded rings and cup products. This I have talked about in my lectures on cohomology. So here we are just going to talk about Steifel Whitney classes. So say you're given a vector bundle E, you have a projection map, and with it you can associate a sequence of functions, these W1, W2, so on, and each of these W1 lies in H1, W2 lies in H2, then Wi lies in Hi, this cohomology group. And from these cohomology groups you can construct your standard graded ring, so which is nothing but direct sum of cohomology groups. So depending upon the isomorphism type of E, you can have certain axioms. So these axioms have been taken from Hatcher's book on vector bundles. So this Wi of a pullback is equal to taking pullback of the class. So this pullback and these classes commute. Now this is very important construction. You take the direct sum of vector bundles. This is nothing but the cup product of this vector bundle E1 with E2, and this W is equal to 1 plus W1, with W1 will lie in H1, W2 will lie in H2, and so on. So this is our, and this is our graded ring. So this W is the entire graded ring. So 3 is that Wi of E is 0 for I greater than dimension of E. And then we have a special axiom for Rp infinity. So this W1E is a generator of H1 Rp infinity Z2. So now let us see these axioms in action. So the total Steifel Whitney class, I'm just going to copy this thing down here. So W of this vector bundle is 1 plus W1 plus W2 and so on. This obviously says W1 lies in H1, W2 lies in H2 and so on. Now you want to multiply these two. You can multiply, and so you just collect the terms. So again, think of it as polynomial multiplication. So this will be, say, degree 1. This is, you're collecting the terms in degree 2. So you have W2 V, so this should be V2 here, and W1 V1. So 1 plus 1 is again 2. So here just 1 1, degree 1, and then you will have degree 3. Degree 3 will consists of W3, then you add to it V3, then you add to it W2 V1, then you add to it W1 V2. So this will give you degree 3 and so on. So that is what the multiplication is. So we can write it like this: W1 plus V1 is equal to A1. So this I'm writing like this because when you will multiply two Steifel Whitney classes, so here you're multiplying two of them. So this cup product means that you are going to multiply them. This is what it is going to look like. This cup product is going to look like this, precisely this. So I'm writing here V1, V2, V3 and so on, so that you know which element is coming from which side. So say WE1 is this side and this WE2 is, say, this side. So this is how you will multiply them. And then I'm just equating it that you know after multiplication this will be degree 1, this will be degree 2 element, and so on. So obviously this side is now this side, W of E1 direct sum with E2. So because this is also a graded ring, this is also, so we have just shown how to multiply two graded rings, which you could have just thought about homogeneous polynomials and sorted it according to degree. So that is it. I mean, the crutch always for a graded ring for me is the homogeneous polynomial. So I just think how it will act in homogeneous polynomials, and it acts precisely that way here. So now let us start applying these four axioms. So for a point, you have, for I greater than 0, you have this equal to 0 because the dimension of the point is 0. So if I is greater than 0, this Whitney class would be 0. Obviously for a single point, W0 is just 1. In fact, there is no W0, you start from W1, so this is just 1. So the Stiefel-Whitney class for a point is just 1, because in higher degrees it will be 0. But you know, if it takes take the pullback of a point, it will also be 0 by this. So if you take the pullback of a point, so this will be a pullback of a point. If E is a point, then you can take the Stiefel-Whitney axiom here. So if you take the pullback of a point, it will be 0 by this axiom 1 right here. So but the pullback of a point is a trivial bundle like this. So then you will have this thing for I greater than 0. So the trivial bundle has 0 Stiefel-Whitney class. Again, 0 means this W1, W2, W3, everything is 0. This 1 still remains. So the 1 is still there. Now say if some bundle E1 is stably trivial. So for example, we saw that the tangent bundle is stably trivial. So that is, you can find another trivial bundle. So you can find another trivial bundle E2, which would make this direct sum trivial. So that is the definition of stably trivial. And obviously now we are going to apply this axiom 2 here. So if this E1 direct sum with E2 is trivial, then this side WE1 direct sum with E2 will just be 1, because W1 would be 0, W2 would be 0, and so on. So this side I have written as 1. Now E2 is also trivial bundle. So E2 is trivial. So this E2 is trivial. So this is also 1. So that implies this WE1, you're taking its cup product, means cup product is just multiplication like this. So you have a bunch of 1 plus W1 plus W2 and so on, and you're multiplying it with 1, but there is 1 here. So all these have to be 0. So this WE1 also has to be 1. So that would imply simply that this E1 is also has a trivial Stiefel-Whitney class, and this you can easily apply to the tangent space example. So since tangent space is stably trivial, that would imply that its Stiefel-Whitney classes are 0 for I greater than 0. Now we talk about the canonical bundle. Now we're going to use this number 4. So if you have a canonical bundle E1 over RP infinity, then you cannot find a trivial bundle E2. That is, if E1 is canonical bundle over RP infinity, it cannot be stably trivial, because you cannot find a trivial bundle E2 such that E1 direct sum with E2 is trivial. Now if such a thing happened, we will use 2 again. So then we focus on the left hand side. So if you could direct sum it with the trivial bundle, then the left hand side, this will become 1. So 1 is equal to, but you know this W1E is generated of H1 RP infinity Z2. So this WE1 at least is 1 plus omega. So that means WE2 would be, has to be 1 plus omega inverse. So that is what we are writing. So this AI is 0. So this is 1. So given this W of E1 is 1 plus omega, so this is given to us. So W1 is generator of this, where omega is here. But then this WE2 is 1 plus omega inverse, and 1 plus omega inverse you can write like this, 1 plus omega square, and so on. This you can do so because your coefficients are in Z2. So negative becomes plus, and so where omega is not 0. So this is a contradiction. So this omega I is not 0. So this omega I not 0 contradicts this part, because at some point in time, if you're going to take E2 as a trivial bundle, it will have a finite dimension. So say its dimension is n, but then according to this formula, there is omega n plus 1 term also in this formula, and this omega n plus 1 is not 0. So if 1 plus omega inverse you could write like this, it will also have some term here like omega n plus 1, which will not be 0. But we have to have some 0 after you exceed the dimension of the trivial bundle. So we have just given some examples for application of Stiefel-Whitney classes and shown and talked about what they are.